Today we're going to be talking about combining rational numbers, and this week, all week, we're going to be talking about fractions because fractions seem to freak everybody out. So we're going to spend a good while on fractions, adding and subtracting fractions, and so we've already done integers. We did decimals for a couple of days last week, and this whole week we're going to spend on fractions. So you're going to make a notebook entry, and this notebook entry will be uploaded to me in Schoology in one of your assignments. So make sure that you either put this in a notebook or put it on a piece of paper that has holes in it so you can keep it. So today we're going to be talking about combining rational numbers. And we talked last week about what a rational number was. This is notebook entry 4. And let's put fractions underneath. So we talked last week about rational numbers. They could be integers, they could be fractions, they could be decimals, they could be perfect square roots. But one of the main parts of the definition was that rational numbers can be represented as P over Q. So if rational numbers can be represented as P over Q, that just means fractions, where P is your numerator and Q is your denominator. And we mentioned that Q can not be 0. That was a big point last week, that Q can never be 0. And we talked in class about why Q can't be 0. Q is your denominator and it represents your whole, and the P is your numerator and represents your part. Well, you can't have part of nothing. So let's talk about pizza. If you have no pizza, you can't have a slice of nothing. So if your denominator is 0, you know automatically that this is not a rational number. That seems like a pretty good quiz question, and we're going to have a quiz at the end of the week. So you need to be thinking about all these little pieces of your rational numbers and what might be on that quiz. Okay, so we know from previous years that there's something special about fractions, and that is fractions have to have the same denominator if you're going to add or subtract. So let's put that in purple. Fractions have to have the same denominator. In order to be added or subtracted. And that is a big flashing lights statement. So let's give it some flashing lights. This is like one of those light up boxes that you see on the side of the road that's flashing, telling you, hey, this is important. Look at me, look at me. You cannot add fractions if you don't have the same denominator. You cannot subtract fractions if you don't have the same denominator. So that is super extra duper important for you to know. And that also seems like a great quiz question to me. We'll probably have a test of some sort next week. So that quiz will kind of help me figure out what exactly I need to help you with before the big test. So That seems like a really good quiz question to me. Wink, wink. Fractions have to have the same denominator. So let's give ourselves some examples. So if I have 3/4 plus 2/4, the first thing I'm going to check is, do they have the same denominator? Yes, they do. So they have the same denominator. That means I can just go ahead and add. I do not add the denominators. I just bring it straight over. Because remember, your denominator represents a whole. So you don't have two different things here. This is the same kind of thing. So this is a pizza and this is a pizza. You're not changing that it's pizza, right? Okay. And again, we know that this is positive and this is positive. So our signs are the same, so we're going to add. So you're only going to add the top numbers. So 3 plus 2 is 5. Now I know that this cannot stay this way because 5 is too big for 4 and it's just going to fall over. So you have to reduce it by dividing the top number by the bottom number. So 5 divided by 4 is 1 1/4. So that would be my answer. So in other words, 3/4 of a pizza plus 2/4 of a pizza equals 1 whole pizza and 1/4. What would that look like with models? So if I have a pizza and this tells me it has 4 slices, and it doesn't matter how many pizzas I have here, I'm just going to put a couple there so I can see what I'm doing. Okay, so this one says 3/4. So that means that I have 3 slices of pizza here. So when I add 2 more slices, I don't go to this side. I have to fill this one up first. So now I have 1, 2, and my model matches. I have 1 1/4 of a pizza. So there we have it. 1 whole pizza and 1/4 of another pizza would be 3/4 plus 2/4. But what if I don't have the same denominator? So if I don't have the same denominator, actually let's make a little note here. Let's do it in blue because this is what I'm thinking. They have the same denominator. So I keep the same denominator and only add the numerators or the top. And I call this my thought bubble, so I just kind of make it like one of those little thought bubbles that you see in comics. This is what I'm thinking. They have the same denominator, so I keep the same denominator and only add the numerators. Please don't add the denominators. I noticed at the beginning of the year, several of you did that, and you can't do that. So make sure you're not adding denominators. Okay? So let's say, what if they have different denominators? And I'm just going to make a little line across here so we know we're on a different kind. Okay, so these are same denominators or like denominators. So this is going to be unlike denominators. So if we have unlike denominators, that's what this would look like. If I have 3/4 plus 2/8 equals. Well, that would be kind of hard for me to model, wouldn't it? If I had a pizza with 4 slices and then a pizza with 8 slices, that would be hard for me to tell what I really needed to do. So what I'm going to do is find a common denominator. So how do I find that common denominator? Well, I look at my problem and I see that I know that 4 times 2 equals 8. So all I would have to do is convert this one to 8s to find a common denominator. So let's do that. How would we convert it to 8s? Well, what I would do is I know that 4 times 2 is 8. And whatever I do to the bottom, I have to do to the top. So 2 times 3. So what does that give me? That gives me 2 times 3 is 6. And 2 times 4 is 8. I'm not going to do anything with this one because now I have the same denominator. But I am going to bring it down here. 2 8s, and I'm going to bring my addition sign down also. And again, of course, we know that these are both positive. So now that I have the same denominator, I'm just going to bring this denominator over. And now all I have to do is add the top. Positive 6 plus positive 2 is positive 8. And I see that 8 over 8 is a whole, and this is how I like to represent that. That is one whole. 8 over 8 is equal to 1. So let's write over here and let's make another thought bubble over here. So they don't have the same denominator. So I have to make one. I have to make a common denominator by doing the same thing to the bottom that I do to the top. It has to be the same or it will not work. Once I have a common denominator, I bring it over and add only the numerators. Okay, and that's a thought bubble, so I'm just going to put it in like a little thought bubble cloud here. I kind of ran out of room. All right, so that's my thought bubble. That's what I'm doing in my head. This is for unlike denominators. This will be your notebook entry that you will submit to me in Schoology. I had several last week who did the work, but they didn't submit their notebook entry, so they lost half of their points for that assignment. Please don't forget to put in your notebook entry. I mean, it's a big slide that says, put your notebook entry here. And then sometimes I have people tell me, I don't know what the notebook entry is. And that tells me that you didn't watch the video. So make sure you turn this notebook entry into me so I know that you did it. And make sure you put it in a safe place so if you need to reference it later, you can. Now let's practice. You have some practice. Let me put this to the side. Okay, so we're going to practice. So let's say we have 6/8 plus, let's say 2/3. Now that one's not as easy to look at because there's nothing times 3 that gives me 8, and there's nothing I can divide 8 by to give me 3. So I need to think of what is a common denominator. And if you don't know anything right off the top of your head, you can always just multiply the two bottom numbers and you know that's going to be a common denominator. It just so happens to be the least common multiple anyway. So our common denominator here is going to be 24. So how do I get to 24? If I want my common denominator to be 24, I know that 8 times 3 is 24. So that's what I get here. And then I have to do the same thing to the top. So 6 times 3 is 18. I bring my sign down. How do I get from 3 to 24? I know that 3 times 8 is 24. And 2 times 8 is 16. Don't forget, you have to do the same thing to the top that you do to the bottom. Let me see if that light helps. Does that help? I think that helps a little bit. Okay, so now all we have to do is add. I don't add the bottom numbers. I just bring it over. My denominator is 24. I don't add it. Now, 18 plus 16. I don't like to add this way. I like to put it up and down, so that's what I'm going to do. 8 plus 6 is 14. Carry my 1, and I have 34. So my top number is 34. And I know that I cannot keep that improper fraction, so I am going to divide 34 by 24. I know that 24 will go into 34 one time. And I'm left with 10. 10 is less than 24. I'm not going to write remainder 10. I'm going to write 10 over 24. So I can reduce that to 1 and 10/24. Now, I notice that is still two even numbers. So I know I can reduce them even further. So I'm going to reduce them by 2, and that's going to leave me with 1, and 10 divided by 2 is 5, and 24 divided by 2 is 12, and that is my most simple form, 1 and 5/12. Okay, let's do one that has the same denominator to begin with. That one's easy. I don't have to do anything to this because they already have the same denominators. So I just bring it straight over. It's going to stay 8. And then 7 plus 5 is 12. Now, that is an improper fraction. I cannot leave it like that. So I'm going to come over here and you divide the top by the bottom. 8 will go into 12 one time. Subtract 12 minus 8 is 4. 4 is less than 8, so I know I have to stop, but I'm not writing remainder. I'm writing 4 over 8. So I know that this is equal to 1 and 4/8. And I know that 4/8 will also reduce to 1 and 1/2. So this is my lowest form, 1 and 1/2. Let's do 6/12 plus 5 eighths. Okay, I'm looking at this, and the first thing that comes to my mind is 24, because I know that 12 times 2 is 24, and I know that 8 times 3 is 24, so that would be a common multiple between the two. So I'm going to go with 24. So how do I get to 24? 12 times 2 is 24, and whatever I do to the bottom, I have to do to the top. 6 times 2 is 12. Bring down my plus sign. I know that 8 times 3 is 24. And whatever I do to the bottom, I have to do to the top. So 5 times 3 is 15. Now, my denominators are the same, so I'm going to bring it over. And 12 plus 15 is 27. I realize that that is an improper fraction. It's too top heavy. So I have to divide 27 by 24. 24 will go into 27 one time. That leaves me with 3. And I'm going to write that as 3 over 24. This is where you get your denominator. Okay, so that leaves me with 1 and 3/24. Now, I know that both of those are divisible by 3, so I can reduce it. So it's going to give me 1, and 3 divided by 3 is 1. 24 divided by 3 is 8, and that is my most simplified answer. Okay, adding fractions should not be new to you. You've been doing it since 5th grade. You did a little bit in 4th grade. You did it in 5th grade. You did it in 6th grade. Now, so we're just practicing with the positives today, and later this week we'll practice using when they have different signs also. So we'll get there, but today we're just doing when they have the same sign. So that should be easy. So this is your assignment today, and I just wanted to make sure you knew how to do it. So I want you to see here that it says start. So you always start wherever it says start. And it looks like a lot of stuff going on. But what you're going to do is you're going to start, and this says 3/4 plus 1/4. So I would go to my paper. Let me get a new sheet. It says 3/4 plus 1/4. I see that my denominators are already the same, so all I have to do is bring that denominator over, and then I add the top. 3 plus 1 is 4. Now, I know that that's equal to 1 because 4 over 4 means it's a whole. So I'm going to come back, and I'm going to look for the 1. You can look here. That says 2/4. That's not 1, so that's not the answer. Here says 2/9. That's not 1, so it's not the answer. But here it says 1. So I'm going to go up here, and I'm going to choose this arrow. I think it usually looks like this. I've been playing with it before I did this. So you're going to go up, and it's going to look like this. And then I'm going to choose the arrow. And I am going to draw my line from here to here, or my arrow. So I know which way I'm going. And then notice that these extras popped up. So I'm going to change my line color to something Miss G can see. So it can be red, it can be blue, it can be anything but what it is. So just make it bright so I can see where you're going. And then I would like for you to also change the line weight to like an 8. So it makes it, I don't have any question on where your arrow is going. Okay, so my arrow tells me now that I need to do 3/9 plus 5/9. So I'm going to come back to my paper, and I'm going to do 3/9 plus 5/9. My denominator is the same, so I'm going to bring it over, and 3 plus 5 is 8. So let's see if we can find 8 ninths on our paper. Okay, I see that this says 2 ninths. That's not the answer. This says 2/3. That's not the answer. But here it does say 8 ninths. So I'm going to go back up here and I'm going to pick my arrow again. Oh, it was already picked. I could have just went ahead and done it. And I'm going to drag my arrow to here, and it shows me what's the next problem. So my next problem is this, 2/3 plus 1/3. So you'll solve that, you'll find the answer, and then you'll draw your arrow to the next one. Now you also have one with unlike denominators. So that will require you to find your like denominator first. So you're turning this one in, and you're also turning the one with unlike denominators into me today. So you have 2 assignments today that need to be turned in. I hope you have a great day, and we'll see you when we see you. Bye-bye.